All right, let's get started. Thank you everybody for joining Applied AI for Marketers. My name is Guy Yalif and I'm the CEO of Intellimize. I've spent the last couple of years trying to put artificial intelligence in the hands of conversion rate optimizers and marketers to improve their online interactions, drive more engagement, and ultimately drive more revenue and conversions. For me, that journey started years ago when I coded an expert system in college to design airplanes. And I've also been a marketer in paid media for the last 15 years, helping marketers across industries at places like Twitter, Yahoo, and Brightroll. I want to make you a better consumer of AI, specifically AI in marketing, by poking holes in what you're hearing, getting more out of your investment, and choosing the right tools for you. My team and I believe that AI can help each of us accelerate our business, deliver more to our customers, and get a lot more done. In the next 40 minutes, we're going to talk about the different kinds of AI that matter to us as people trying to grow businesses, walk through some concrete examples about how AI can help us, and discuss questions that'll help us get the most out of an AI investment. Please ask questions anytime throughout. I see several people have already said hello on chat. Fantastic. Thank you very much. Feel free to ask there. And if you're going to ask a question, don't use the Q&A. Not everyone can see it. Use chat and address it to everyone. It'll be like one big conversation. And I'll pause from time to time to go through them. All right, let's begin. So what is AI? Anyone have a guess? Why don't you throw it there in the chat window? Any guesses? Well, I'll share that AI is often defined as machines doing things that we as humans would consider intelligent. And while for some of us, that might conjure images of like Terminator movies, turns out AI is already part of your daily life. It's all around you. I mean, the companies on this screen today probably helped you avoid spam emails, figure out how to get to work, write more grammatically correct messages, manage your money, and recognize friends in pictures simply by looking at their faces. AI as a concept's been around for a long time. Greek myths contain stories of mechanical men designed to mimic our own behavior, and very early European computers were conceived as logical machines that reproduced capabilities like basic arithmetic and memory, and engineers saw their jobs then as like attempting to create mechanical brains. And we've come obviously a long way since then. So to Antre's question from Job, what's the difference between machine learning and AI, and can we use them both for marketing? Excellent question. We're going to go directly into that. And to preview, I will frame machine learning as one branch of AI. AI is the umbrella. You've got rules-based AI, machine learning-based AI, and some other kinds, and we'll go through that. And I think in common usage, people use them interchangeably. A machine learning person probably would say they're different. And then the question is, how can we use AI in marketing? Great segue. Turns out we've been using AI in marketing for a while and have a lot more that we can do. So our paid marketing peers have been using AI out in the open for more than a decade. I mean, when Google says, hey, give me 5 paid search ads, I'll figure out which one to show each individual searcher to maximize the probability of click. They're using AI to do that. There are other practical examples of using AI in marketing today. Persado is using AI to automatically craft engaging email subject lines. Or for B2B marketers who are looking more mid-funnel, Madkudu and Infer are examples of companies that are training models to predict the value of a lead so that you can engage prospects more when they're higher value and send them more to self-serve when they're lower value. More towards the bottom of the funnel, both Drift and Intercom and others have enabled marketers to set up rules to engage prospects in real time as they visit your site. And Optimizely similarly enabled rules-based action by doing A/B testing with audiences. And it happens my company Intellimize uses machine learning to automatically pick the right variations to show each visitor, kind of like Google and Facebook do for ads, but now for websites. This is by no means exhaustive, like not even close. It just helps illustrate some of the topics we want to cover. So as you can see, like AI is pervasive in your personal life. It's also growing and more widespread in your professional life. We're going to dive into AI itself in a minute, but I want to start with understanding you better. So please go to this link, bit.ly/CXLAI. And what you're going to see there is this, a question for you. We're going to answer 2 questions to describe what kind of work do you do? What role do you have at work? And we're going to see the results here in real time. Thank you. Please keep clicking on these. And then we're going to ask one more question just so we get a sense of who we are as a group. I'll give you a few seconds to go to that page and fill this out. Just give everybody a couple more seconds to go to bit.ly/CXLAI and fill things out. Oh, thanks, Kate. Oh gosh, I am so sorry. Yes, I should have not been covering up the URL. All right, we'll wait just a couple more seconds. Okay, this is who we are. We're mostly growth professionals or conversion rate optimizers. A bunch of us are PMs. Fantastic. Now we're going to go to the next question, which is how well do you know AI? From, hey, I know how to spell AI to like, I code AI every day and I have a degree in it. Please answer this. We'll all take a look and then we'll keep going in the course. Fantastic. It seems like we are dialed in together. This webinar is aimed at folks who have a sense of what AI is, but want to go deeper. It's for somebody with no experience or beginner experience. Somebody who's an expert may find this helpful in being applied with AI, but we're not going to go into coding or the math behind it. Thanks, everyone, for filling these out. All right. We're going to together cut through the hype of AI. It is a super popular buzzword, quite overused at the moment. Think it can help change your career for the better. Think it can help you deliver more results more quickly for your companies. And we want to cut through that in this webinar today. You won't exit this webinar or the course that follows as a machine learning coder, but you will be able to talk intelligently with your data scientist about the problems AI solves, have better intuition about what the AI terms mean for your business, and ask better questions, either of your internal team or of vendors when you are talking with them. So why is AI useful? What's it good at? Well, when focusing on website optimization, there are a bunch of things it's good at. Anybody have a guess what these numbers are? Well, the first one illustrates how well AI is good at managing a lot at once, an awful lot. In fact, 4.5 billion is the number of versions of a page a great B2B growth hacker, Guillaume Cabanet, shared on a CXL stage a year and a quarter ago. It's superhuman to manage that many, and it helped him drive great results. AI can also help us massively accelerate testing, and 25 is that number of years worth of A/B testing our average customer did last year. That kind of acceleration can help your team deliver more results and insights. And unlike us humans, AI who get tired and distracted, AI is great at listening 24/7. 4 is the number of hours it took AI to react when a customer of ours ran a big promotion, significantly increasing their traffic. And it turns out the new traffic behaved really differently. The right answer changed in the moment, and AI was able to respond. And finally, AI is really good at acting with precision. AI is good at finding signal in a noisy environment and acting on it, and 1 is the size of the segment AI can optimize for. In fact, these 4 things together help us as marketers deliver the vision of one-to-one marketing that we've been talking about for a long, long time. It practically can be achieved today. So with that as context, what does the AI tree look like? Well, experts will disagree on how to structure it. Here's a reasonable point of view, and one that many would agree with. And it begins with 3 branches: before AI, rules-based, and machine learning. We'll cover them now and then go deeper into machine learning itself. So before AI, we know well. It's an approach familiar to us. When we're doing A/B testing, we code an idea, set up a 50-50 traffic split, look at the results every day as they pour in, make an educated guess about when to call a winner, choose the winner, and then ask engineering to code that onto our website to show everyone. It's great because it enables us to make better decisions based on actual prospect and customer actions. It also puts the execution on us and assumes that the right answer now is the right for everyone and forevermore. Okay, so that's the manual approach, very familiar. The end result is a winner to show everyone. Some of us then ask, hey, what if my audience is not all the same? What if they actually behave a bit differently? And that then takes us to rules-based optimization. And rules tend to look like this. You'll say, hey, if someone's in San Francisco, then show them the Northern California promotion. That is great because we get to show different experiences on our website that are more likely to drive conversions, and we're not treating everyone the same. A rules-based approach is particularly useful when you've got a business rule. You absolutely cannot show this thing to someone else. So it's very helpful then. Marketers often will intuitively say, hey, that's not AI. But most data scientists would say this is AI. This is knowledge-based AI. And in fact, most A/B or personalization companies who say they do AI are actually doing this. And there are many examples of this throughout the funnel. You can do email marketing drip campaigns in Marketo, chat bots with Intercom or Drift, some forms of content recommendation, ad retargeting, even some forms of lead scoring are done this way. Now, marketers would see this and say, hey, I want more. I want more lift. So they'll add more rules. And they usually take this form, right? Some audience page or context. If that shows up, then show a particular message offer image. And often we'll then say, okay, I want even more. And we'll say, I want a huge number of rules. In fact, if I created a rule just for every city in the United States, I'd have 35,000 of them. I then need to maintain them over time. And in practice, we usually top out at tens of rules. Rules-based AI in this context is great because it helps us personalize our messaging to each visitor, but it's brittle and doesn't scale. And it's typically implemented either with A/B testing using audiences or rules-based personalization, which again, most personalization vendors are doing when they say they're doing personalization, or with a kind of AI called an expert system, which is effectively a way of handling a zillion if-then statements. And here is one example of an expert system. This actually is the paper I published off my thesis a long time ago in college to do airplane design. So rules can be quite powerful. And again, they're very helpful when you've got a business rule. They're also really helpful, in particular for machine learning folks, before you go into machine learning itself. Why? Because if you can achieve a bunch of the logic you want your algorithm to achieve with rules, it often can be cheaper and quicker for a machine learning scientist to try it out with rules and get a sense of, hey, does this all hang together? And then go try the machine learning. So it can be sort of a precursor. And if you're thinking to yourself, okay, well, which one's better, rules-based or machine learning? If you go to a data scientist or AI expert, they'll tell you, I don't know, I need to try them both. And the right answer is whichever one produces a better result. That's practically how it's done. Okay, so we talked about before AI with A/B testing, rules-based AI. Now we're gonna go talk about machine learning. Machine learning itself is, just as the name says, about learning. It's technology that gives us leverage by coming up with rules on its own and learning from data. It's not automation. Automation is about a human giving a set of rules that a technology system executes rapidly and reliably. Like if you're gonna merge a database to populate and send emails for a drip campaign, that's automation. A machine learning system will optimize. It will learn rules. And in order to do that, we need to give the machine something to optimize for. A conversion rate, a CTR, revenue, engagement. So With machine learning, you get automation and optimization. Machine learning is applied to aspects of problems that complement what humans do. I firmly believe AI is not the end-to-end solution. It needs to be complemented with what we do, and we'll talk more about that. I see, Job, you asked a question, is Intellimize similar to sentient AI? I'd be happy to answer that one-on-one. Here, I want to stay product agnostic and just talk about machine learning and AI in general. So feel free to ping me afterwards. I'd be happy to talk about it. When you're thinking about ML, you can think back to like a kid's brain. It's inherently wired to learn. And as an example of how machine learning optimizes, think about when either you as a kid or your kid, if you have them, tried to ride a bike. You try riding a bike and you fall. And okay, maybe you adjust a little bit to the right and you ride for a little bit and then you go too far to the right and you fall again. So then you get up and you're like, all right, well, I went too far right. I'm gonna try to go a little more left. You start leaning left and that goes okay. Maybe you go too far and you fall again and you balance again. It takes experience over time to find the right balance. You go a little too far one way, a little too far the other. Machine learning works similarly to try to predict the right answer over time based on experience. And to make that work, we first need to give it some data. You know, for the kid riding the bike, the data is like, I'm riding and am I falling? For machine learning, we need to be thoughtful about the data we give the machine, make sure we have as much as we need, the right kinds of data. Some machine learning problems require Google levels of traffic. Like if you're going to train AI to play chess, you need, you know, millions, billions of games of chess to learn. Other machine learning approaches take a lot less data. Then, second step, you train a model. And the model is learning from the data. And you got to make sure you've got the right kind of model for the problem you're going to solve. And there's no one-to-one mapping. Like, you know, Matt Kudu's model to predict lead scores is probably very different than the model you need to automate A/B tests. And we'll talk in this webinar about some rules of thumb that can be valuable there. And then the machine will make a prediction. The model will. It'll make a prediction that hopefully optimizes the result you're looking for. The result, if you take this approach, machine learning can auto-generate a zillion rules for you, auto-discover segments for you, auto-update those over time. It can help you accelerate conversion rate optimization. And in fact, it's used in a bunch of places today. We talked about some earlier. Some forms of content recommendation use it, some forms of lead scoring, predictive personalization, audience lookalike modeling. There are a bunch of applications for it today. I hope now to go deeper into ML itself. We talked earlier about what AI is good at in the context of conversion rate optimization. I want to take a half step back, broaden our lens, and talk about what is AI good at, what is machine learning good at in the broader context of marketing, not just CRO. Before we do that, I'd like to frame how a typical machine learning scientist will think about things and what it means to them. If you have questions as we're going through this, feel free to put them in the chat anytime. So machine learning itself, the guy who coined the term said, machine learning is a field of study that gives computers the ability to learn without being explicitly programmed. Now, this was his point of view. But if you ask a bunch of machine learning practitioners, there's not a universally accepted answer of what machine learning is or how to structure the tree. Again, we'll cover here a thoughtful, well-researched point of view that'll probably resonate with most machine learning practitioners and is hopefully approachable and useful for all of us as marketers. Now, we talked about machine learning being based on prediction, based on known properties learned from training data. It tries to get better and better at predicting to achieve some goal over time. And there is no specific rule you need to set up. You're a machine learning scientist, they're thinking through a bunch of things as they're trying to create an algorithm for you to do that optimization. Often they are thinking in this way, and I want to share it with you so you have more insight into getting more out of machine learning either directly or by working with your machine learning team or with a vendor. So first, they're usually thinking, what's the problem I'm trying to solve? Like I'm trying to ride a bike. Okay, then what AI group of problems does this map to? There's a certain classification of problems, which we're going to walk through next. And I want to map your problem to one of those. I want to see, is the structure similar? Then they'll think to themselves, all right, well, if I'm going to do that approach, what data do I need? And can I actually get that data? Sometimes the data you need isn't easily obtainable. Sometimes you'll spend 6 months going door to door, surveying people on things to get data for your model, and that may not be tenable for you. And finally, within that group of AI problems, they'll think, okay, what algorithm should I choose? And there's not a specific answer every time. They'll try something, see if it works. And if it doesn't, try something else. Sound familiar? It's a lot of what we do when we're doing conversion rate optimization. So what kinds of AI problems do ML scientists map to? What's ML good at? Well, we'll focus our answer on marketing. We won't cover things like autonomous driving cars. And let's dive in to do just that. On the left, we're going to talk about a set of problems that we as marketers might be thinking about. And on the right, we'll talk about the type of machine learning problem that might map to. Now, there are many, many more branches in the AI tree than what we'll talk about here. I believe these are the differences that matter to us as practitioners. Data scientists will spend a lot of time, as my team does, on the right version of AI, but these differences are the ones I think we as marketers can get the most value out of knowing. So when you're talking to a data scientist, they'll often use the language on the right to describe the big area of ML they're thinking about. So first class of problem I'd like to talk through is regression. That's the machine learning version of it. As marketers, we might think about something like lead scoring. Like, hey, somebody came in, I want to score them from 1 to 10 on my website so that I know, do I send them to sales or do I send them to self-serve? Or ideal price, what should I price this product at? Or what discount should I give someone? What's the ideal promo value? These all map to a class of problems called regression. And that means predicting some continuous value. And by continuous value, I mean like a number, right? If lead score could be 1 to 10, and there could be a zillion gradations in between. A price, there are infinite number of prices you could choose. I contrast this with the next kind, which is called classification, where you're doing a similar prediction, but now instead of sort of this range of values, you have a specific set of values, discrete values like success or failure, yes or no. Here are some examples. Will this person click on an ad? Yes or no? Now we could do lead scoring again, but instead of giving us a range of values from 1 to 10, I might just want high, medium, low. If I want that, this then becomes a classification problem, not a regression problem. I might want to say, hey, is email spam or not spam? Making sense so far? Feel free to share feedback in real time on chat. These are the two kinds of machine learning you will hear about first and most often. There are a bunch of others that are relevant for us. We may want to choose a product to show. We may want a product recommender, or we may want to choose which content we want to show to somebody to keep them engaged. There's a whole class of machine learning problems called recommendation that will help solve that and give you a prediction of which product to show. You may separately want to do conversational commerce. And I don't mean the bots from Intercom and Drift. I mean more like Alexa and Siri. You might want to understand speech through natural language processing. Or you might want to recognize the content of an image, right? You might have a magazine image of a star, and you may want to recognize, hey, that handbag is in this image, so I want to put that handbag next to the image so somebody can buy it, right? You might use ML to do that. Or you might, like Persado, want to write the email subject line. Speech and image recognition are a host of algorithms sitting underneath that type of problem for machine learning experts. Totally separately, you may say, I want to segment my customer base. Now, here, you've got a bunch of data about your customers, and you're looking for, like, what are the patterns? What are the clusters in here? Clustering helps you do that. You may also feed a clustering algorithm a whole bunch of insight, a whole bunch of data about your business, and have it try to surface insights about them. Next thing you might do, you might want to detect fraud. As somebody's coming through your site, you might want to know, hey, are they fraudulent? Or you simply might have a bunch of data about customers and want to know, hey, is this person an outlier in some way? And there's a class of machine learning problem called anomaly detection that helps you do that. You don't need to memorize all of these at all. I want you to know that these are some of the typical terms folks will talk about in machine learning. And the last one I wanted to share was, if you want to send a sequence of emails and you want to map out the whole sequence together to ultimately achieve a goal, reinforcement learning is a great way to do that. Parts of conversion rate optimization also lend themselves to reinforcement learning. And it's characterized by, like, chess. Chess is the prototypical example of reinforcement learning. In chess, when you're playing, you know ultimately if you won. I'm pretending like here's the end of the game where you win. There's a whole bunch of steps you make in between. You don't know how you're doing in between. Reinforcement learning is good at saying, well, I made all these moves, I won. Now, let me, for my next game, learn something about the probability of winning, the value of each one of these interim steps towards winning. I only got input here, but I want to infer input along. I want to infer the value of steps along the way. Just like if I'm sending a sequence of emails, ultimately I want somebody to do something, and I need to infer what's the value of each one in between. Michael, question. What's the difference between clustering and classification? Great question. Classification would be, I want to predict success or failure. So, and I've got data telling me, was there success or failure? For example, let's pick the lead score one. I've got data on 100 current customers, and I know, based on my internal analysis, for those 100, which ones are high value, which ones are medium value, which ones are low value. I'm going to use a clustering algorithm, excuse me, I said the wrong word, a classification algorithm, to then predict the next 101st company that comes in. I'm going to use a classification algorithm to predict, are they going to be high, medium, or low value? So I've got training data that already tells me, hey, high, medium, low, and I'm predicting high, medium, low going forward. That's classification. Put that aside. Clustering, I don't have any indication about the structure of this data. I've got my customer database, and I know, Joe is a man and how old he is and where he lives. I know Jane is a woman and how old she is and where she lives, and a bunch of data around them. I want patterns to emerge. I want the machine learning to find out, hey, I'll make it up. I've got a cluster of, millennials in New York, and I've got a cluster of Gen Xers in Iowa. Whatever it might be, I didn't tell the machine, I want to know Gen X versus millennial, or I want to know Iowa versus New York. I didn't tell it that. It figured that out on its own. I just see segmentation is making classification, clustering, distinction hard. Got it. The difference here is that in classification, you are telling the system, here are the classifications I want. I want high, medium, low, or I want yes or no. In clustering, you're not telling it in advance. In clustering, it's figuring it out on its own. And I'm going to go one step further before answering Job and Marov's questions. Thank you for sharing them. The step further I wanted to go gets a little bit to Michael's questions. And specifically, the top group of problems, machine learning scientists would call them supervised learning. Why? What does supervised mean? It means you know the answer in your training data. For example, just what we talked about. You have a bunch of companies and you know their lead score. The data you feed the algorithm to train it, you know the answer. You know these 100 companies, how many were high, medium, and low. You're then creating an algorithm to predict the lead score of future companies based on what you've learned from the training data. Success is predicting the correct score. And machine learning scientists would call the training data for supervised learning labeled, because you have the right answer attached as a label to the example. In this case, those 100 companies, the high, medium, low, that's the label. Now, the next group are called unsupervised algorithms and problems. Why? Because you don't know the answer. Just as we talked about, if you've got a bunch of data about users, but you don't know what clusters there are, you don't know if the relevant cluster is male, female, or millennial, Gen X, or New York, Iowa, or some other thing. You don't know. You want it to find it out. You want it to have that come out of the data. Machine learning scientists would call the training data for this unlabeled, because there's no right answer. You're not trying to predict that specific thing. And the last group is reinforcement learning on its own. And it's different in 3 ways. And then I'll go answer the questions. Number one, the algorithm in reinforcement learning takes action itself, and through the action it takes, it learns something different. What do I mean? For example, let's say the algorithm chooses to send a particular email. The algorithm has to choose one action from a series of possible actions, right? One email from a set that it could send out. It only gets to learn the outcome, the result of the one it chooses, right? If I have 5 emails I can send and I send number 2, I only get to learn the result of number 2. I will not get to learn the result of the rest. So that's one difference. Difference number 2, as a result of that, reinforcement learning algorithms must make a choice. They must make a choice between, I'm going to get more performance right now because I know, I'll make it up, I know number 2 is a high performer, versus I'm going to go learn something because I don't know much about email number 4, but I'm going to send it anyway because I need to learn, is number 4 an even better performer than number 2? For those that are familiar with explore exploit, that's exactly what I'm talking about here. It just needs to decide whether it's going to exploit its existing learning by sending out number 2 or explore something new by sending out number 4. And finally, reinforcement learning is different because of what I mentioned before about chess. You only know a label, the result, on the final step. You don't know it for each of the interim steps. To contrast the explore exploit part, for example, supervised learning, which we talked about up above, it's in some sense, it's all exploit because it's always trying to predict the best thing that it can do. There's no notion of, I'm going to choose something that I'm not sure if it's good so I can learn. So I hope that helps frame these. Now I'm going to go to the questions. How is anomaly detection different than classification? Isn't it simply classifying an event as an anomaly or not? It's a great question, Job. There are some similarities. In fact, anomaly detection, I put it here as unsupervised. Sometimes people will give you supervised data. They'll give you labeled data. They'll say, hey, I'm going to train your algorithm on this group. And this group, they're all normal. They're not anomalous. They're not abnormal. And then I'm going to feed you additional data. And your job is to figure out, is this normal or is it an anomaly? And so you're right. You drawing the similarity is very right. The math underneath anomaly detection is very different than the math underneath classification, but they are similar in that regard. Anomaly detection can work with no labels at all, which classification cannot. Where does predictive analytics fit in here? So it depends on Marov, it depends on the kind of predictive analytics you have in mind. For example, if it is, I'm going to predict lead score, we talked about 2 versions, right? Where I'm going to predict a continuous score from 1 to 10, or that's regression. Or if I'm going to predict a discrete high, medium, low, that'll be under classification. If you have other things in mind, please let me know. And Gabe, what platforms or tools would you recommend for recommendation? Great question. Maybe ping me offline afterwards and I'll share some suggestions because I want to know a little bit more. Are you trying to do product content? In what context? How big? How much data do you have? One thing to know about recommendation, it often involves a bit more work because you're going to want to feed that algorithm a lot of what you know about the product or the content, right? It's going to do a better job if it knows, I'll make it up. You know, this is a cup, it's plastic, it's red, it happens to be filled with water right now, right? Okay, the water isn't important, but like telling it more data, feeding in your whole product catalog and current prices, it'll do a better job so it can be a bit more involved and it can be very, very powerful. Any other questions on this slide? I want to be thoughtful to your time. These questions are excellent, and this slide was intended to take a while. Thank you for the questions on it. Feel free to follow up. I know we have about 10 minutes left, so I'm going to try to get through a bunch of the rest of the material. So this is the theory, right? There's this nice map from here's a problem to here's the class of machine learning problem we'll use to solve this, and then there are algorithms underneath each one of the things on the right. Reality doesn't typically look like this. Reality tends to be, frankly, a lot less one-to-one. I'm going to give you 2 examples to show what typically happens in machine learning. And this is part of why it ends up being a more difficult thing to do. It's not as simple as, I'm going to pick the right algorithm off the shelf and I'm done. Turns out that's usually, I don't know, 20% of it. There's a lot more. Here's one example. Realistically, Machine learning scientists will often combine techniques from different parts of the tree to solve the specific issue they're facing. And then they keep tuning their algorithms and putting together different techniques until they find a setup that delivers the results they need. Said another way, there's no universal answer. And this is part of why it's easy to say AI, but hard to get it right. You need a bunch of experience. So on the left, we have the different ML problems we spoke about before. On the right, here's a typical way they might be put together. I might want to recommend some content for somebody to engage with. I might first begin with classification algorithm to decide of all the content I have, is some of it offensive and not offensive? Okay, I'm going to take the not offensive part. Then I'm going to run that through another classifier that's going to tell me, is it popular or not popular? Then I'm going to focus on the popular stuff. I'm going to take the result of that, and then I'm going to go through clustering. And I'm going to do collaborative filtering so that I can look at all the actions other people have taken to tell me what's interesting or not. And out of that, for you as the individual visitor, I'm going to have a ranked list based on the score of what content should I show you. Then as a result of that output, I'm going to apply a rule. And that rule is going to say, it's a business rule. I decided I want no more than 2 pieces of content from any one category. As you talk through these, it seems totally realistic and reasonable that somebody recommending content to engage with would run through these. But as you can see, this is a lot more than just picking the algorithm from the left. So that's one way it often happens. Another way is that machine learning scientists will run multiple algorithms together. Why would they do that? Well, turns out pretty much all these algorithms have some dial you need to tune in the back end. And it's not clear in advance what that dial should be tuned to. So experience will help set realistic ranges of values, and then you use a bunch of trial and error for the rest. Machine learning engineers will often use multiple copies of an algorithm, let them each make a prediction. Like here, you see 5 regressions running in parallel. They then might use the algorithm that says, hey, I am most confident about my output. And there's a way the algorithm can say that I'm most confident. So for example, when you show up, it might choose regression number 2's output. And when your friend shows up, it might choose regression number 5's output, because each one has more confidence. Or they might take these 5 and do it totally differently. They might say, I'm going to use 10% of regression 2, 50% of regression 5, and so on. Which, by the way, then means they have yet another dial to turn, because they got to figure out how much of each regression to use. This is real life for machine learning scientists. While there are a few other applications of machine learning we've heard about in the conversion rate optimization space, I'd like to sort of share that, like in broader marketing, it takes them a while and a bunch of experience to go tune the algorithm they want to go deliver the results they want. Now, there are a couple of other applications of AI in conversion rate optimization, and I thought I'd talk about them just for a second. Some vendors say they're using AI to accelerate the choice of a winner-take-all winner. For example, some will say they accelerate reaching statistical significance by picking a winner early, showing more traffic until it reaches statistical significance. That's one way to do it. They're sort of applying some heuristics and rules. Other vendors will say, I'm going to look at a full factorial multivariate test, all the possible combinations of some ideas you're running, and I'm going to narrow down the universe of potential global winners, because I'm going to pick one winner. I'm going to pick one output. And I'm going to then run a smaller multivariate test and pick a winner more quickly. I've heard genetic algorithm once being used this way. I've heard other vendors say they're going to use AI to recommend rules to drive personalization. So the system itself is not writing rules, it's recommending them. It's saying, I saw this pattern emerge, and I'm going to surface this to you as the optimizer, and you can accept the rule that's been recommended out of the system or not. There are plenty of other applications of AI, like self-driving cars, financial services, a whole bunch of others. But these are ones that are specific to CRO. Now, none of these approaches work without data, and I'll briefly go through this. Finding the right data can take a bunch of work. Making sure it's actually clean sounds super simple and is often quite hard, because you won't realize until the algorithm's functioning a little oddly that there was some problem with the data that you received that wasn't obvious. And figuring out how to represent the data can be hugely time consuming. As an example of how do you represent the data, What time is it now? I'm in Pacific. So is it 9:11 a.m.? Is it morning? Is it Friday? Is it July? Is it the year 2018? All of those are true. All of those are different ways of representing the time right now. Machine learning algorithm may produce wildly different results based on those different representations of the time. It may produce different outcomes. And so machine learning scientists will often spend a bunch of time figuring out what's the right way to represent this same truth. Now, more data, typically it's better. In particular, if you have an algorithm that's based on a lot of inputs, a lot of variables. It's sometimes happen that a mediocre algorithm with a boatload of data to train itself on will outperform a super duper complicated, awesome algorithm that doesn't have much data to train itself on, which I use to illustrate the point that like picking the right algorithm, I don't know, maybe it's 20% of the problem. Now, getting more data is not always better. One, it can be super expensive to get. I've seen and heard of many times where somebody will go spend 6 months and a lot of money trying to get data that didn't actually help their algorithm, and they could have known that in advance. So that's another thing you can know. And experience can help a bunch. Experience can help you know a lot whether more data will help and what kinds of data to use. To get it right requires more than an algorithm. To our previous slide, you need good, clean data. You also need experience. Like often smart people will use algorithms in ways that have little chance of success, or they'll spend 3 months when someone else who had experience with that algorithm, that kind of problem, could have pointed them in a different direction from the start to increase the probability of their success. Practically knowing how to apply algorithms can save a lot of work. And even among experts, with the right experience, there's often not universal agreement on the right approach. Second, you need to tune the setup you've chosen, including both the algorithm and the data. You can spend a lot of time and resources with the right algorithm if you don't know how to practically apply it. I wanted to leave you with a few additional thoughts as we get towards the end. As you're thinking about how to bring this to life, you often will think through, hey, should I build? Should I buy? I propose some of the benefits are here, where with building you get full control and you get to customize it exactly to your needs. It can take a longer time to get the benefits, but then the benefits could be like org-wide. The single biggest challenge with building is talent. Talent is crazy expensive right now. And actually, even if you want to spend the money, it can take a long time to find the right people with the right experience. Buying, the benefit usually is you get the benefits a whole lot faster. It's often less expensive than having in-house talent. The cost is that it's less customized, and that may be good enough. It may not be. You may need some talent in-house to work with the vendors, but it's often easier to find talent that's less expensive. When is AI not the thing for you to do? I strongly believe it's not the end-to-end answer for conversion rate optimization. To do CRO well, you need customer intimacy, where you understand and empathize with prospects and existing customers. You need ideation, where we do creative work to design variations to connect our products and services to prospects' day-to-day lives. And you need management to build and manage experiments. To date, AI's not been great at creativity or empathy. We as marketers, we're uniquely suited to drive customer intimacy and ideation thanks to human creativity and empathy. Now, when is AI not right for you at all? I agree with Alex completely. I think there are 3 reasons why. One is just what you said. You're getting like 10 page views a day or 10 conversions a day. If so, typical data-driven marketing approaches overall probably won't work for you. We've seen as a decent rule of thumb, I don't know, if you're getting 1,000 pages a day, 50 conversions a day, the balance between getting results quickly and getting the benefit of AI can be pretty good. Reason number 2, you got a bunch of hard work to do that AI is not going to help you on. Like if you don't have product market fit or you have churn all across the board, go do the hard work of talking to customers to get product market fit, or go fix the core product to go reduce churn. And third is if you don't have any time at all for anyone in the org to spend on web optimization, don't use AI. It's not going to go do it on its own. It'll provide leverage, but it doesn't replace sharp minds thinking about prospects and thinking up creative ideas. Because we're at time, I'm going to skip through some examples that brought this to life. We can go through them if you're interested in continuing on a course afterwards, and I'll mention that in a minute. And if you want, please ask and I'll go back to them. But I invite you to consider these questions when you get back to the office on Monday. You're probably in the office now, but let's say it's Monday, because I think AI can help you with each one of them. First, is my audience all the same? And if you say it is, I'd say, really? It's kind of like saying every man on this webinar needs to wear a size 10.5 shoes, because that's the average shoe size in the US. It's silly when you talk about shoes, but we do it on websites all the time. 2, do you know your testing velocity? What would happen if it doubled? What would that mean for your business? 3, do you know when your site visitors' behaviors are changing? Are they different than they were a week ago? Are they different than they were 2 months ago? And if you did know, what would that mean for your business? And last, I'd suggest asking yourself, hey, am I able to deliver the right experience to each person? If I could, what would that mean for my business? I invite you to think about AI as an opportunity for each one of us, a superpower that can enable our teams to deliver more revenue and customers and drive more insights and accelerate our career growth in turn. Rather than threatening our jobs, I actually think AI is a great complement to our jobs. And I believe the time to differentiate on it is now. Roll the clock forward a few years, AI will be pervasive in optimization. Why? Not because I believe it, but because there's simply too much money sitting in this approach. So if you like having an army of analysts helping you manage a lot at once, try out AI. I invite you to go out there, harness the power of AI, advance your career, go test more, go learn more, go deliver better results with it. And with that, I'll ask, do you have any questions? As you're dialing in the questions, I want to suggest, if you'd like to go deeper and learn more, CXL is starting a course on AI that'll take these very concepts and flush them out further starting Monday. It's twice a week for a couple of weeks. Please join if you're interested. Simply Google CXL Institute Live and you'll see it listed at the top of the course section. Questions? Or feedback? Did you find this useful? Are there ways you would encourage me to make this better if it's ever done again? Awesome. Thanks, Michaela. Marov, will the webinar recording be shared? Yes, it will. CXL will generously share the whole recording afterwards. Thanks for asking. Vivek, thank you for the kind words. Much appreciated. Rodrigo, do we have examples of AI ML techniques that could help in the initial phases of CRO, the research and analysis of traffic? I have examples in this deck on if you have ideas, how can you get the most out of them? And I'd be happy to go show those if that'd be helpful, Rodrigo, please let me know. On the research and analysis, I think some of the clustering can help, and a bunch of it is for us as humans to do, looking at the behavior of our visitors to go inspire ideas for where we might have impact. Lannis and Marov, thank you for the kind words. Very glad you joined. Wade, yes, a dictionary of the terms used. That is a great idea. And I think the slide from, this slide, I think, is the best one we have for that. And we'll see if we can't put something together as well. Thank you, CXL, for sharing the recording. Alex? Great. And Alex saying, hey, I want to apply AI with current clients. You triggered one thing for me that I wanted to share. We sometimes have people say, and it's not what you're asking, Alex, but just because you triggered it, I'm not ready for AI. I don't understand A/B testing well enough. I would humbly submit, you are totally ready for AI because you know your target customer, and AI will save you time of learning a bunch of the rote experiment mechanics you need to do with A/B testing. I'm not saying it's better or worse. They each have their place, but it can help those that aren't deep experts in A/B get straight to conversion rate optimization and spend more time intimately understanding prospects and less time on mechanics. Cool. Any other questions? I'll wait for about 30 seconds. Okay, Thank you everybody for joining today. I appreciate your participation. The feedback was super helpful. I hope you found this valuable. And if you want to follow up afterwards, please at Twitter, Guy Yalif. Would be happy to connect afterwards and look forward to seeing maybe some of you next week. Have a great rest of your day. Thanks for joining.